Okay, here we are again. I'm making a video on the operations with functions. This video is targeted for either Algebra 2 classes or pre-calc classes. So some of this will be, almost, I don't want to say common sense, but it'll be pretty obvious, and some of it will not be obvious and will require a little bit of insightful thinking. Okay, I'm going to start. So the operations that we're thinking of, at least the basic operations, the addition, subtraction, multiplication, and division. Now, normally we do operations like this with numbers or variables, but in this particular case, we're actually going to do the operations with functions. So we're going to add functions, subtract functions, multiply and divide, and so forth. So the notation would go something like this. There's a couple of ways of writing notation. Let's say I have some function f of x, and then I'm given another function, and I'll do the specific examples on the next page. This is just the introduction to the notation. The next function maybe I'll have is like g of x, and one more. Theoretically, there could be lots more, but for the most part, we're going to do two, at most three functions at a time. So, and then there is like f, g, h of x functions. Okay, and if I'm, for instance, if I'm doing the addition operation, I could write it one of two ways: f of x. Well, I don't know why my colors keep changing on their own. F of x plus g of x. That would create, it basically creates a brand new function, which is a linear combination of these two. It's combination, or it could be written as f plus g, kind of like this, with x to follow. Now, it's not, sometimes students in the beginning are confused by this notation, thinking that this is like you take f function, you add g function to it, and then you multiply by variable x, but that's not the case. You're not multiplying at the end. This is just a notation. It's sort of almost like a lazy way of writing this, because it just saves you from writing parenthesis x parenthesis twice, and you just write it once. But really, this is a more common way. But yeah, nevertheless, you should be familiar with this, because this does come up frequently enough that you should be familiar with it. Okay, and I think I'm going to start on specific examples. So I might as well leave this. Next example. Okay, so I have a couple of examples here. So you're given g function and g and f functions, and you're simply literally adding two functions together. So you could either write them out as if you're doing g function. Here's the g, negative x minus 3, and then plus. And you can, if you wish, kind of use parentheses, or not. Especially in the case where it's a plus, you really don't have to worry about distributing negative. We'll see the second one where there's a minus in front. You just have to be a little bit more careful not to lose a negative sign. But in this case, I'm going to actually take those out, and the f functions to follow, which is 3x squared minus 2x. And I could have done some of this mentally, just combine like terms. Clearly what's like terms here is like, this combines with this, and the rest does not combine. So I'm going to list this out in a standard notation or standard form. So the highest exponent's listed first, 3x squared. Now when you combine negative x and negative 2x, so it's minus 3x, and then followed by what's left is just minus 3. And that is my answer to this part. Okay, so that's my answer. I'll put a box around it. So that's my final answer. Okay, let's jump to the next one. You have to be a little bit extra careful when you have a minus between the functions, because what you're doing is subtracting, and you put a minus basically in front of the whole function. Here's the g function. So one way to write that, there's a couple of ways, either mentally or literally on paper. And minus 1, that's your f function. Now you can write minus, open the parentheses, and insert the g function right there. So negative 3n squared plus 5n, close parenthesis, and simplify. Now you have to be careful about the minus sign in front of the parenthesis. When you open up, everybody on the inside gets that -1 distributes and changes sign. So you could say n minus 1 plus 3n squared, and then minus 5n. And again, you are looking for simplifications, like terms, and there is nothing common between this, so just continue. So again, I'm going to write 3n squared first. This becomes -4n. Let me turn the music down a little bit. Okay, so continue, and so -5, so this is this. And what's left is -1 at the end, and that is my final answer here, which is the solution to this question. Okay. All right. So yeah, it's pretty straightforward. You could, I don't want to say you could skip all this. If you've never had this, you still want to see this. However, this follows logic and common sense here, what we're doing with the functions. Okay, next. I'm doing, okay, I didn't mean that. I'm doing multiplication. So this will feel like, because I have two terms and two terms, they're basically binomial times a binomial, well, I'm going to list it out first. N minus 4, that's my g function, followed by the f function is -3n to the third minus 3n. And it feels like a what? Well, it feels like a FOIL, which is exactly what it is. It's you're doing double distribution. So let's go. So this over here, this over here. So that part becomes -3n to the fourth, right there, to the third power times that, 1. So then this becomes minus 3n squared. I'm gonna run out of space here. I should have, let me actually move this a little bit so that I have a little more space there. Okay, continue. So continue in the second part, or this part right there. So -4 times this, and then -4 times this, and I'm gonna continue here. So -4 times -3 and cubed is plus 12 and to the third power, right? Third power. Okay. And what else? Sorry, so -4 times the second part of, the last part of the FOIL, the L. So -4, this is plus 12, and what power is just n. So now we combine like terms, but it looks like there are no like terms. 4, 2, 3, 1. So yeah, there's no like terms, so nothing really combinable. However, you should still write this out in a standard form. In other words, the polynomial should start with the highest exponent, so right there. So the answer is -3 and to the fourth power. So that took care of this. Then followed by the cubic. So plus 12 and third. That took care of this. Now the second power, then followed by that. So minus 3n squared, which took care of this, and then plus 12n, and you are done. So this is the result of FOIL. Basically, it is FOIL. Especially, it's a FOIL if you have just two terms times two terms. Obviously, the functions themselves, like this function, could be a little more complicated. The original function, I could have had another term here, like let's say plus 5. Well, it would be a lengthier process, but logically speaking, it still would be the same. It still is just distributive property. Okay, let me erase that. And so jump to the next one. So the next two, I noticed they're pretty much the same. Oh, okay, the notation is a little different. Okay, that's fine. So in fact, what I'll do is I'll do this one first. I'll do 5 first, and then I'll jump to 4 to kind of indicate, that where the pitfall, where students can make a mistake thinking that's a multiplication by n. So let me do this problem right here. Okay. All right. So this might look a little bit weird at first, but all this is basically saying 4 times the g function is like 4 times the g, whatever g is, and I'll just insert it in a second, and then minus 5 times the h function. Again, I'm gonna just insert it in here. So this really is the g function is goes inside here. So this is 2t plus 2, and this is the h function is t cubed minus 3t squared. Okay. And this is, by the way, this is called linear combination, because you're combining different functions in a linear way. In other words, you're not really squaring. This is not like g squared. You're just combining. Well, that's what it's called, linear combination. So when before you combine them, you have to distribute here. So this really becomes what? 8t plus 8. Right? Then minus, and this becomes 5t cubed, and then plus 15t squared. And again, it just feels like nothing's combinable. It's just by coincidence. That's just, very often there is something to combine at the end, but here we have third power, second power, single power, and t to the, in other words, no variable. So again, it might, I could leave the answer like this, but if this is, more acceptable ways, rewrite this in a standard notation where this comes first. Oh, sorry, I took my outline. Yeah, the highest power is, so negative 5t to the third plus 15t squared plus 8t, and then plus 8. Okay. And that is the answer to this question right there. Okay. I'm going to jump. Actually, I didn't mean. Okay, what just happened? Oh, what just happened? Okay. My recording window just moved. Okay. All right, so we're going to jump over here, and I'm not going to go through the problem because I'm just going to emphasize what this notation is. This is not you doing 3 times g minus 2 times f and then you're multiplying by n. You're not doing that. This is just a notation. So in fact, I guess I could do it. It's pretty quick, so might as well do it. So this really is 3g minus 2f. That's all it is. This it feels like you're multiplying by n, but you're not. So 3 times g is this. So I might as well just do this mentally. 3 times g is 6n minus 3 times negative 2 is 6. And then I'm going to actually write this out just so that, you first of all, you see where it's coming from. Second of all, I don't make a stupid mistake. Because of negative 2, I'm multiplying. Well, I guess I could have. It's easy enough. So I'm negative 2 to this function. Well, this is n to the third. And then negative 2 times negative 3 is plus 6 at the end. And again, I'm probably overemphasizing. I do not multiply by n. This is not a multiplication. So this is it. And I'm looking for any simplification. And in fact, I do see one. Negative 6 and positive 6 cancel, and the rest is just, I'm going to write negative 2n cubed plus 6n. And that is my answer to the linear combination of this, right there. Okay. Okay. And last problem, at least on this, right. So the last operation is the division. Yeah, there's really nothing inherently different about it, except for you have to be careful about, since you're dividing by, you know, theoretically you're not allowed to divide by zero, so theoretically there could be a little bit of a problem here. So in this case, g function, this is like just a notation. This is g of x divided by f of x. Again, it might feel like you're multiplying by letter x, and you're not. This is what this means. Okay, and in that case, the g function's up top. The g function is this. This is 2x minus 3. The whole thing divided by the f function. And the f is x to the third minus 3x. And although you can, I mean, you can leave the answer like that. Depends on the question, because I don't see anything that could simplify. They could combine somehow or cancel. In this case, that's not, can't be done. However, the question also might ask you list excluded values, or list its domain. Domain means, what are the possible x's that you're allowed to plug in. Well, into the original g and f, you could plug in anything you want. The domain is all reals. The domain is all real numbers. Okay, for either one of them. However, because you're dividing by a function, the denominator can't be 0. If it is 0, then it's undefined at that location. Whatever that makes whatever x makes that the denominator equal 0, we have an undefined point. Meanwhile, you may not see it, but the way to get that is, well, if I could factor first, so up top there's nothing to be done, x minus 3, but in the denominator, if I could factor x out, and this becomes x squared minus 3, and so what values are excluded? What values of, okay, let me actually clear whatever that is. Clear that. Okay. So what value is excluded here? Well, x is not allowed to be what? X is not allowed to be 0, for one. I can see if I plug 0 in here, it doesn't matter what's up top. The zeros up top are fine, but in the denominator, if I plug 0 in here, then the whole denominator becomes 0, and that's excluded. That is not, you're not allowed to divide by 0. Okay, that's one. But I also notice you may not recognize there's going to be 2. If you were to factor this, or even if you weren't to factor it, what is the value of letter x that would make this equal to 0? And there are in fact 2 values. X equals positive square root of 3, and x equals negative square root of 3. And because those values would make the denominator equal to 0, I'm saying they are excluded. They're not allowed. You're not allowed to plug them in. If I were to graph this on Desmos or whatever, you would have vertical asymptotes there. You may not know what I just said, because if you're not familiar with vertical asymptotes, that's a topic for a different video, sometime in the future. Anyway, so what's excluded are 3 values. X equals, this. Kind of like this. Those are excluded. So even though it still is a basic operation, division, it makes it a little bit more complicated if the question goes a little further and says, well, which values are excluded from the domain? Okay, and I think I'll stop right there. I mean, hopefully that was clear enough. Through a couple of examples, you should still practice this, but through a couple of examples, you would fully understand this. Okay, next I'm going to stay on this topic, operate on same operations, except for now we're going to actually have plug-in values in here. Instead of letter x, we're going to have x gets replaced by some fixed number. Here it's 9, and so on. Well, you could proceed it. You could do it one of 2 ways, and one of them is obvious. Well, I shouldn't say obviously, but one of them is definitely easier than the other one. So if all I care about is this, just one example, like I could theoretically find what g of x plus h of x combine them first, and then plug into the final result. However, that feels overkill. That feels like overkill, or feels like a way, much more difficult than it needs to be, because if all I care about is this value, I'm going to do the following. I'm going to plug in 2 into the first function, into the g function, find the value of it, and then do the same thing for the h function. So if I plug 2 in, this becomes your input, and the result is the output right here. So I plug 2 in here, this 2, and so this is what, 4 times 2 is 8. I'm going to write 8 plus 5 equals 13. So that's this part right here. So that's 13. And I continue plus, and if I do the same operation over here, 2 in here, this is 8, right? 2 to the third, minus 2 squared, which is a 4. So this part is 4. So the final answer here is 13 plus 4 is 17. That's your final answer for this question, for this. Okay. And notice, on the previous page, when we had the input was the variable x, and the result will be in terms of letter x. Unless something completely cancels away, but that's rare. Your final answer here will be in terms of x. But in this situation, since we have an input, a numeric value input, we're going to get a value as an output of the final result. Okay, not an expression in terms of x. All right, so same idea here. Now I'm just going to fly through this a little quicker, because if these become plugins, this really becomes pretty quick. So 9 in here, so this is what, 81, right? 9 minus 2, so that's 79. So this part is 79, followed by a minus, and you have to be careful about the minus part, that's all. So if I plug 9 into here, this becomes negative, 9 times 4, negative 30. So I'm going to write negative 36 minus 1. So make it what, 37? Negative 37. So it's a minus a negative 37. And that's the thing about the negative, about the subtraction. You have to be careful about this extra minus sign. So this is whatever this is a plus. So this becomes so 6, right? So this 6 goes here. That's 8. So this looks like 116. Yeah, I think so. Right? Yeah. 70 plus 30 is 100 plus and 16. Okay, good. Okay, final answer. Right. To this. Okay. Well, to this whole thing. All right. So we'll. I was going to say continue, but yeah, I might as well. I mean, it should be pretty quick, because it's a plugin of -1. So if I plug -1, oh right, remember this is not this times -1. This is a notation. This is the same thing as h of -1 multiplied to the function g at -1. That's just a notation thing. That's just the way it's written. Okay. So let's plug -1 in here. So what does this become? -1 minus 3 is -4. So this is -4 times, and then -1 in here. So what does this become? -1, right? -1, and then a -1 in here. Then -1 squared is 1. So this is plus 3. So this is positive 2. Okay. And so this is 2 here. And the overall answer is -8. Okay. You could pause, and if I'm going a little too fast, and hopefully I'm not making any silly mental mistakes, but you could always follow and check me. Okay. Next we have this division situation, but in this case I don't have to worry about so much. What am I plugging in? What's the excluded value? Because if I plug 6 and my denominator equals to 0, then I know that that's a bad point, or that's a bad location. However, you know, if I get anything less, anything different from 0, then I'm fine. All right, so let's do this. Let's plug 6 into the numerator. Negative 4 times 6 is 24, negative 24. So this is negative 27. And you could, you know, do it on paper. So what about the second one? 6 in here is 36. I'm going to write 36 plus 6 in here, 24. So this part is 60. So the overall answer here is the g function of, this is g of 6 divided by g of 6 divided by h of 6, like this. Again, it's not times 6 at the end. And so my numerator is g of 6 is this, is negative 27. And the denominator is 60. So, you know, I noticed that 3 goes into both, top and bottom, because this is 3 times 9. And this is, you know, okay, so this is negative 9. I'm going to reduce both top and bottom by 3. And this is 20. And it does not reduce further. Okay, and that's my final answer. Is it worth doing one more, kind of like this one right here? I don't know. I guess. I mean, it's, you know, we came this far, so might as well. This thing keeps moving. Okay. So here we go. So plug. Oh, okay. Let's do this. Be careful. It's a linear combination. So it's a 4, and I'm gonna do this minus 3. And let's plug 5 into here first. So plug 5 in. This is 25 plus 2 is 27. So this is your f at 5, or f of 5, and then you have a 4 in front. So 27 goes here. And let's plug 5 into the letter G. And in this case, this is 10 minus, so this, 10 minus 3 is 7. Right, just kind of confirm it. Right, yes. And so that is a 7 here. And when I simplify this, this is clearly 21. And what is this? Well, this is 4 times 25, which is 100, and then 2 times, so it's 108. And this works out to be whatever it works out to be. So this is 7, right? 7, yeah, and then 87. Just a little bit of mental math. Okay, not a big deal. All right, so I think looking over the whole thing, and here's the whole thing. You know, if you have any questions, if you have any, you might pause and just kind of go through this yourself to verify my answers and verify your skill, of course. All right, let's move on. So this is full screen, and next page. So yeah, we're coming to what's, you know, the new operation. So everything up to this point is just, you know, like your addition, subtraction, multiplication, division of functions. Now we're coming across a new operation which you may not be familiar with. It's called composition, or composing functions, but you know, usually it's just called function composition. Okay, and you're creating a brand new function out of some kind of existing functions. So we'll talk about what the operation notation is, and there's 2 notations for it. And also we're going to talk about, well, how many functions can you string together? And theoretically, infinitely many, or not infinitely, but, you know, some large number, you could just keep stringing them together. However, realistically speaking, we usually, you know, do 2, 3, 4 probably at most. Okay, I mean, yeah, it's possible, but I'm only going to demonstrate probably just 2 functions, maybe, I don't know, maybe a third. I'll see what the computer generated. Anyway, the notation is the following. So, you know, there's 2. Yeah, as an example, if I have 3 functions, I'm going to write f of x. Then I will have another functions g of x, And all of these are, of course, defined. I just don't want to do it, off the top of my head because it may not work out nicely, uh, whatever this is. And then so F, G, and typically we use these letters, kind of middle of the alphabet. Okay, letters. All right. So the notation is if I want to create a function that combines these two in a composition kind of way, this is going to be written either like F O G, kind of like this. And this is not a multiplication sign. This is not a dot. This is like a little bit of a circle. It's definitely not a big circle to make it like this. It's not this, because this might look like I don't know, like, well, that actually looks pretty good, but it could be confused for 0, and it's not. So it could be written like this. It could also be written like this, F O G, and this is an X out here. Again, what might be confusing is you're thinking you're doing some operation here, and then you multiply by letter X, and you're not. This is a sort of a lazy way of writing this. However, what it really means, what this operation means, is the following: F parenthesis G of X, and the order absolutely matters a lot, which letter is listed first. I'll close the parenthesis, so there's double, like there's outside parenthesis and there's inner parenthesis. So the order matters a lot. This is not the same thing as GOF, and I'll show you example why that's not the case. This is not the same thing. So I'm gonna undo that. Okay, and let's kind of make sense of this. What this is saying, you're going to take whatever X, you're going to plug it into the G function, which is typically, this is what you have. You're given this. But whatever this is, you're going to plug into the F function wherever you see a letter X. This goes plugged into whatever you have a letter X throughout this F function. And with specific functions, it'll make a little more visual sense. But that's really what you're doing. You're definitely not multiplying these two functions. You're plugging one function into another function. Okay, and so that's the notation. This is a one, I think, I don't want to say it's easy to understand, but it's easy. It makes more logical sense what you're doing here. Whereas this is just a quick way of writing F-O-G. That's how I pronounce F-O-G. Technically speaking, it's like F of G of X. That's F of G of X. Okay, and how many functions can you string along? Well, technically, you could do it. If you're given 10 functions, you could do that. However, in reality or commonplace, we're going to do 2 functions at a time, or at max 3 functions, like what this is. But for today's lesson, I think we're going to do only 2 functions. Okay. When you get to calc, yeah, it does happen. It absolutely happens where you have like three functions. One function inside another function, and that in itself is inside another function. In fact, I'll write it. I'll write it like this. If I have 3 functions, it could theoretically be like F, and what's inside here, and I'm just H. And what's inside here is G of X, kind of like this. And I just have to be careful about the pairing up of my parentheses, right? So these pair up, this pairs up, yeah. So I'm good. So the idea here, I'm going to take I'm going to take the G function, and I'm going to plug it into because it's inside the H function. I'm going to plug it in here. Notice how it's inside, where normally it's just, H of X, but instead of X, I have an expression. And then that result, that whole thing, whatever this works out to be, I plug it into the F function and simplify. Okay. All right, so let's get through an example or a couple of examples, and you'll see it's really not that difficult. The order absolutely matters. which one is listed first. So in this case, what am I doing? Well, I'm taking the g function, and in this case, the computer said n, but typically it's x. Or so I'm taking the g function, and wherever you see, and plug it into f, meaning you take this expression and you plug it into wherever you see letter n, the variable, in the other function. But in this case, this is pretty straightforward, pretty simple problem, because there's only one place right there. So this answer here is really, really simple. This is like 2 of something minus 2. Notice how I wrote this. It's really just the f function. And now I'm waiting to plug in the g inside where normally the letter x or n goes. So this is negative 2n squared plus 5n. And by simplifying, I am creating a brand new function. It's a function composition. So in this case, this is what? Negative 4n squared, right? And then plus 10n, and then minus 2 on the outside. And you're done, because there's nothing to combine here. There's no like terms for me to combine. This is my answer. And I created a more complicated function out of 2 existing functions. Yeah, this is really useful in pre-calc. I mean, right now it just feels like I'm just learning a skill, a very mechanical skill. But in pre-calc, and especially in calculus, okay, it's useful. All right. Anyway, so let's do a. In fact, maybe I should demonstrate how different my answer could have been if I reverse these 2 letters. Let me see if I want to invest the time. Yeah, let's do that. Let's do that. So what I'll do here, instead of doing this. Yeah, because this is pretty simple. This is just a, yeah, it's very simple. You just take this and you plug it into the letter x, and then you simplify. I mean, it literally is like 10-second problem. I'm actually going to do the more difficult. I'll show you how it can be challenging, because the operations can be challenging, but also that the order matters. So let me clear up some space. What am I doing? Okay, I remember. And okay, I'll just cover that up so I can use that space. And here we go. So now I'm going to do, instead of doing F-O-G, I'm going to say G-O-F, which really means I'm plugging F, the order matters here. I'm plugging, this is like G, and inside of it resides f of x. That's what this is, which is very different from this. So anyway, so what does this really mean? Well, into the g function, I'm going to plug in the f. Well, what's my g? Well, g is right there. So g basically says, well, negative 2, my input, the variable n, squared, plus 5, and the input variable n. But instead of n, I actually have an expression of this. So this is 2n minus 2, and this is 2n minus 2. I plug minus 2. I know I wrote wrong. And then I'll simplify it. So right now you might want to pause and just kind of see the difference, what I'm plugging into what. But I'm going to continue, because obviously you could pause and just think. All right, right now, so the order of operations, I have to do this, this parenthesis, this thing first. So I'm gonna not do everything in my head, although it's not that difficult, but so that you see where the stuff is coming from. So this is 4n squared, 8 minus 8n plus 4, right? Just opening that, and plus, in this case, this is just 10n minus 10. Right, let me just make sure. Yeah, and when I open these parentheses, this becomes negative 8n squared plus 16n, right? 16n minus 8. And but remember, you have the stuff behind here. I'm just going to write this out. Plus 10n minus 10. And what combines is your n's and then your, like whole, integer without the variable. So this is negative 8n squared. They combine to be 26 n, and these combine to be minus 18. And I, unless I made a kind of silly, stupid mistake, a mental mistake, this is correct. Notice it is a big difference, right? There is a big difference between the two. This one versus this. Okay. Let me see if there's anything else to say. No, I think we're good. We can continue. Okay. Let me see what's going on here. I'm plugging I'm plugging this into here. So I don't necessarily. I think when I was creating this, or I let the computer create it, but then the numbers it was creating were a little too simple, and in this case, I think I might have made it not so much too difficult, but just it's going to be a little bit lengthier to simplify, but only because of it, I see a cube, third power here, so it's a little higher. So what am I doing here? I'm taking g function and I'm plugging it into the h function. So I'm taking this and I'm going to plug it into wherever you see a letter t in here, and then eventually simplify it. So let's start. So the g function, the h function looks like something to the third power. Notice I'm kind of opening parentheses, waiting for the input. If I were doing this, I wouldn't be doing this. I would just go right to it. But right now, as I'm explaining this, I want to make sure that you understand where it's coming from. Then my h function says, well, minus 5, wait for the input, and the input is getting squared, and then minus 10 at the end. There's no more input here. There's no letter t. So what's the input? It's this. This is my input. Okay. And when I plug in 2t minus 1, then what? All right, so 2t minus 1. And I'm probably going to leave it this way, although you could FOIL this out, or you could use a formula. There's formulas to go with this. It's just binomial expansion. But because it's not a square, do I want to do this? I mean, it would take me just a couple of extra, basically like half a minute or a minute. But I'm going to leave it like this only because, I don't see that being tested with the higher powers. Or should I just do it? I don't know. Yeah, I might as well do it. So this is 1, 3, 3, 1, right? Yes. Okay. So 1, 1, 1, 2. Yeah. Okay. Well, what I did was, in case you're not following what I'm doing, I just wanted to confirm what my coefficients will be. These are binomial expansion. This is Pascal's triangle. It's just a quick way of remembering these the coefficients. So in this case, this would be. Let me see. Want to make sure I don't mess up doing basic math here. So this is 8t cubed, followed by 3 times 4 is 12 plus 12t squared, followed by 3. So times 2 is 6 plus 6. Oh, actually, it's technically going to be alternating plus minus, and followed by just plus, so plus minus, so minus, and I'm going to change that sign. So minus 1. Okay. If you don't know where this is coming from, don't worry about it. I mean, right now, this is not really the goal to go over this, and this is a minus. Okay, so this is just the binomial expansion. Typically in our Algebra 2 class, yeah, frankly, even pre-calc, we really don't even do this by hand. Uh, not in this skill. I mean, that's a skill in itself. All right, so the next one is minus. Oh, that one's definitely I can do this mentally. So this is 4 times 5 is uh, 20 t squared. Uh, the middle is going to be 4 times 5 again minus. Actually, in this case, it's a plus 20t, right? And followed by minus 5. And then at the end, followed by minus 10 from here. So this right here is the expansion of this. That's this part. And this, all of this, is the expansion of this. Okay. The important thing there was really not this part, but understanding how the composition would have resulted in this. And had this been not third power, but like if this wasn't here, this would have been a much easier problem just without that. Anyway, that particular skill kind of comes to the end, or that's I think that's enough. If you need extra practice, obviously you should get extra practice, but as an intro, this is sufficient. Now, looking at the next problem, this is also a composition, but now it's composition with numbers, with values, input. And the input here is a numeric value. So this actually will be much easier. Well, definitely quicker. So in fact, I guess I'll do it here, even though space-wise I have a little less space, but that's okay. So what am I doing here? Well, I'm doing this first, the inner function input. So this is telling me take 10 and plug it into letter F and figure out what that is. So if I go to the F function and I plug 10 in, this is negative 10 plus 3, which is negative 7. And that negative 7 becomes my input. This yellow, that highlighted thing, is worth negative 7. So what I really, when I simplify it, I have g of negative 7. And now I go into the g function and I plug in negative 7. So the very original input is 10. The result of that becomes an output, and at the same time that's also an input in here. It's an output to the F function, but because I'm plugging that into the G function, this is an input for the G function. So that all sounded confusing, but I threw a couple examples. You should make sense what input output I'm talking about. So negative 7 in here is a negative 49, right? Negative 7 squared is 49 plus 2. And of course, that is negative 47. So the overall answer is negative 47. And again, because the original input was a numeric value, my final result will be a numeric value, not an expression. And that's why these problems are so much easier and so much quicker, because you're not carrying these fancy operations, combining like terms. It's just numeric simplification. Okay, so let's do a couple more, and we'll be, I think, done with this topic. Anyway, so again, because this is a numeric input, I'm going to take 8 and I'm going to plug, basically I'm going to put 8 in here. So this becomes an 8 plus 2, of course, equals 10. So that's the 10 is my output for this part, the result of this. So this really becomes g of 10. And now I simplify that. I mean, I carry out those operations by going into the g function and plug in 10 in here. So this becomes 10 squared minus 10, which is 100 minus 10. So the overall answer is 90 as my final answer. Again, it's pretty simple, pretty quick, as long as it makes logical sense now that you know this new operation. All right, we're coming. Oh, okay. So slightly different. Notice how we're given two functions, right? G and A. I'm sorry, G and H. However, the problem's asking about H plug into H, which sounds kind of like a weird and complicated. How do you plug the function into itself? Well, you can. So this really becomes the way to think of it is as H inside H, but inside it is a 2. So, and because this is going to be all about numeric value, what is this part? Well, this part is I'm going to take 2 and plug it into the H function, and what is this going to be working out? So this is 2 in here, it's 4, plus 2 in here is 6, right? You know, 2, and then minus 5. So this is 5 overall. I mean overall meaning H of 2 is 5. But that 5, even though it's output for here, it's the output, but for the outer function, by the way, I don't know if I mentioned that, I tend to think of these as like inner function and outer function. And I'll go back and actually describe that. So the inner function would be like, in this case, that's the inner, and I think it's pretty obvious why. And this is the outer. So you know, evaluate, you go inside first, and you do that. Anyway, so getting back to this problem. So once this is 5, this what I have here is H of 5. H of 5. So I go back to, again, to the H function, because that's what directions tell me. But now I plug in, not original 2, but the new input is 5. So like plug this in, so this becomes what? 5 squared is 25 plus 15, right? So 5 times, 3 times 5, and minus 5 overall. I mean, that's, so this is what, 10? So it's 35? 35 is my final result of this. This is, that's this. Okay. Again, you could obviously pause and look over my work, rewind if you need to. Let me see if there's anything else to be said about. So I did mention at the end, I kind of, should have said that early, but inner, outer. Oh, I'm actually going to go back to the introduction. And if you have 3 functions like this, right, like you have a string of 3 functions, well, I tend to think of this function is my inner, this function is outer, and this function, this H function, is kind of like the middle, right? It's literally, it's in between the inner and the outer. Yes, in itself it's also inner, it's inside the F function, but you can sort of see that it's in between inner and outer. So this is what I tend to, when I'm in class, we tend to, especially in calc, this comes up in calc, and this is my middle or mid function. Okay. All right. I'm pretty sure that's the end of. So yeah. The next video or next topic would be function inverses, but it would be way too long of a video to combine both of them. All right, so I'm gonna hit pause, or and I will see you in class. Oh, 53 minutes. Didn't realize it was that long.